As we already mentioned in the first part, we're going to focus on the spray now. So we have the foam already set up, and next up is the spray, so the stuff that lives in the air. So let's head over to our scene. Here, last what we did, we cached out the current status of our whitewater simulation. What we already noticed the last time is that the behavior up in the air is a bit strange, and you get like this weird streaky stuff. Overall, it looks a bit doesn't look too pleasing. The main reason here is the adhesion, which is basically trying to keep the white water to the fluid. And since if we have a look, where is it here at our flip sim, we do have stuff in the air here. And if we look at our collision SDF, which is there, you can see it is trying to keep it attached to that part. So let's just quickly get rid of everything else and have a look at it. And then here we can see this is basically where it's trying to stick the white water to the surface. And that's why we're getting this strange behavior, because it's trying to follow this here. So what we want to do is just focus on the behavior in the air, and then we'll try to blend both of them together. But before doing that, let's just quickly go over what we did last time, or go over the result. And so if we have a look at this here, where we can see basically we're interested in the foam on the bottom, so on the lake surface, and as we can already see here, getting some really nice behavior here. Here, as you can see, some nice clumping, and then also these kind of tendrils. And then what we set up before with the repellents is basically so we get different sizes of holes. So here we have like smaller ones, then here bigger ones spreading apart, and this just adds, makes it a bit more interesting. If we go further, we can really see this kicking in. So we have like really big ones here, and then a lot of smaller ones. And now what will happen once we start changing the top part of simulation, this will affect slightly the bottom part, but also to our benefit, because what we will be doing is adding a bit more clumping and stuff like that. So let's jump right in. First, disable our simulation. Let's go into our whitewater simulation here. And so what we want to do is first on the whitewater solver, if we go to the foam tab at the very bottom, we have our adhesion. So basically the effect that it is sticking to the fluid or to the surface field. And first, let's just disable this here. And what we will start to do is change our clumping settings here. But before we do that, first, what we want to change is basically how things are going to get affected. So we want to separate already in this simulation, start to separate into mist and spray. So spray being the main big whitewater parts, like the stuff that starts to get clumped, and then the mist, which is kind of flying on its own, not clumping that much. And so the way we do this, we would just group it. So let's just create a pop group. And what we want to group is basically our emission. So everything that is just born, so just on the first frame when it gets emitted, that would be the just born group. And we want to enable or head over to the random tab and then enable the random, and the chance that it gets added to this group is 30%. So basically 30% of our emission gets plugged into our group spray. So first we have to turn this around. So we want to, this is our source group, is going to be the just born, and then our group name is going to be spray. Just spray. It's all capital, so we can easily find that later. And then next what we want to do is we want to group everything that is missed. So we would just copy that group node, and then we say everything that is just born except for spray, and we want to disable this random and then by rule and then just say in group. So everything that is newly born and it is not in the group spray will become our group mist. So let's call this spray, and then this is going to be our mist. And so now we want to also start affecting those differently. And the main behavior that we do want to do or do want to add here is a drag. But we want to have a different drag for our mist and for our spray. So first, let's just drop down a pop drag. And then let's plug this in to our particle forces. And then this will affect everything except our mist group. And then I'll set this to fairly low, so 0.01. We also want to change this by age. So basically the older it gets, the more drag it has. So in the beginning it doesn't have too much drag, but then the older it gets, the more it drags. So we can look here. Our attribute is called air resist. So we say air resist is equals to, or we multiply this, so times equals to our fitted age, f at age, from 0 to our maximum age. So just creating another general reference here, and then remap that to 0 and 1. And basically this would say, let's just promote our parameters here and set this to something like 2, so that everything that has a age of 0 gets remapped to 0. Everything that has an age of 2 gets remapped to the value of 1. And then this becomes the multiplier for the air resist. So basically, if once it reaches the age of 2, it will have the air resistance of 1, since 1 times the air resistance here stays the same. And the lower this gets, so for example, if we're at 0, if we multiply this by 0, there's going to be no air resistance. And so this is just going to ramp in. And now we want to do the same. So just copy this node here and then do this for the mist group. And here we want to have a very high drag, so 0.2 or something. And then also maybe add a bit to the full drag. So once that kicks in is a bit later. Another thing that does add a bit of interest is a bit of wind, and we want to apply that to our mist. So let's just create a pop force here and quickly set up a wind. So first of all, the group we want to apply this to is our mist group. And then for the wind direction, I think, let me see, I think it's probably going to be in the -x. We'll have to probably check that again once we see this simulated and from the shot camera. But for now, let's just go, I don't know, -1 or maybe a bit higher. So I don't know, 3, 4, maybe just split the half, so 3.5. And then for the amplitude, let's go a bit higher, so something around here. And then swirl scale or swirl size, so basically how big these wind gusts are. Let's just go a bit lower, so 0.8 of the original, and have them pulsate a bit longer, so they're not as short but more like waving around. I think that should be fine. The only thing that we do want to do here is just add another expression here, so just have expression so we can modify things. So once basically do the same thing that we did here using the age and then modifying these parameters. And also what we want to change is basically if they get lower or close to the surface, we don't want to have any wind kicking in, so it doesn't constantly fly away. And so first we want to create 2 multipliers. One is our height multiplier, and then the other one is our age multiplier. So first let's create our height multiplier. So let's define a float here, and then this is going to be our height multiplier, and that is equals to, I'm going to to fit our y position. So fit vector at position.y, and then we're going to say our min height, and then our max height, and then fit this to 0 and 1, and then same for our age. So we want to grab our, let's call this age multiplier, and then let's grab our age. So fit at age, and then from 0 to see if, and then let's call this our max age, and then from 0 to 1. And now what we want to change is first of all, the amplitude and the force. So force being just the direction, and the amplitude being the swirl on the ground. So let's first force times equals, so it's here we have, this is called force, and then we say age mult times our height multiplier, and then the same for our amplitude, since I think this is just called amp, yeah, amp times equals, and then we have the exact same thing here. So let's promote our parameters here. Now min height, so basically where we want to have it 0 effect would be 0. And then the max height where we want the maximum effect, and from where we want it to slowly ramp down. So I don't know, like 1 or 2. Let's go for 2 meters. So from 2 meters height, we have full wind. And then slowly, the further down we get, the less wind we have. Same for the age. Let's just also go for 2, the same that we have here. And so basically what this will do, we will just multiply these together. And so if we have, for example, a height of 0, there's also going to be 0 effect due to also on the age, because we're just multiplying these two together. Also, if it's very high, so it would be a full-on effect by the height, but the age is not very high, so close to 0, then also the effect is going to be low. And that's where you just combine those two, just multiply them together. And then once we have a high age and also a high height, then we'll have the full effect of our wind. And this will just help once this stuff falls down to the ground, that it, or not to the ground, but to the water level, that it will not start to swirl around on the water surface, because that's nothing that we want. Now, the next thing that we want to change here is the clumping. And we do want to have the effect only on our spray. So what we will do here is let's just add a geometry wrangle, and in there we will just specify for our group that it is going to be affected by this or not. And the way we would do this is if we go here to the, this is basically our stiffness, and we can check that inside here. So if we jump inside our whitewater solver, let's just here allow editing of contents, and then search for the stiffness. And then if we look here, this is our ramp that we have on top here. Let me see. Variable stiffness, yeah. And then this is the ramp that we have inside. This one here. And the value that it's using here is PBF stiffness. So let's just copy this parameter. And then outside here, let's just say our PBF stiffness is equals to 1. Let's forget the at here. So PBF stiffness is 1. And this will be our PBF stiffness spray. And then let's call this apply to the spray group. And then we'll have the same for our mist, and then supply this to the mist group, and then set this to 0. And so now we will be setting our stiffness value automatically outside for the mist, and we don't want to have any stiffness on it. So there's no clumping and such gonna be happening for that. So now, since we already started talking about this part here, basically we're just focusing on the top part, and what we want to have is this is a stiffness by depth. And this is the depth range that we have. And so we just want to remap this. And we don't want to have any stiffness inside a surface, so we don't really care about that. So let's just go from 0 and then to the max range. Let's go a bit higher, so 0.5 outside of the surface. We want to have stiffness there applied, and if we set this here to 1, basically this means, so now it's 0, so this is representing 0.5, but everything that goes beyond this 0.5, we also want to apply a clumping and stiffness stuff, so that stuff that is flying away, it also has the clumping happening to it. And so if we push this to 1, I think it also says it in the help here. Yeah, there you can see. So basically pushing the end part of the ramp up to 1 results in all particles that are outside the surface to also get this stiffness or this clumping effect applied. And so we want to set this to a really high value, and then just take this last parameter here and just drag this all the way to the very front. So basically, as soon as it gets outside the surface, then we have a clumping or stiffness applied to our particles here. And so let's just try to get really close here. So 0.01 or something like that, that should be good. For the constraint stiffness, let's going to set this to a very high value. Let's start with the value of 10 and see how that works out for us. And then the next thing that we do want to change here under our advanced tab is basically our, this also applies to the clumping. So basically how many particles we want to have in our neighborhood. So let's say, let's bump this really high to like something like 50 or so. And also for the maximum numbers of neighbors it can have, let's also go a bit higher here. So something like 100 should give us some nice results. And also for the overall behavior, what I do like to add for stuff flying through the air, and also to get a bit nicer, like liquidy feel that starts to keep things together, and also gives a more, let's say, coherent motion where everything moves kind of in the same way. We just add a bit of a viscosity, and so standard, this is very, very low. Let's just go to 0.1 or something and see how that turns out. For the tensor radius, we just want to have them a bit bigger, so let's go for a radius of 0.2. And the rest of this stuff should be fairly straightforward, and just leave as is. Now, one thing that I do want to mention, if you want to get a bit more in depth into all these settings here. So, I mean, we covered the foam part quite in depth. Also this, but there's also a really good masterclass from Side Effects going over the new whitewater solver, which basically also goes through these settings and the stuff that we just talked about. Yeah, but if you read through this here, for example, the inclusion chance is basically the chance for our particles to get included into clumps or into getting constrained together and building these chunks and clumps. Also, same for the maximum acceleration of those chunks and clumps, not going beyond this, the constraint iteration. So basically how often we want to iterate over this until the constraints start to break apart again. Tensor radius for basically creating those like thin connecting lines between different clumps and chunks that we already saw in the foam part at the bottom. We already had some of that, but we also want that through the air. So if there's like two two bigger chunks that are close together and start to separate, we have like this nice in-between line. Also for the strength, just keep this fairly low. I mean, you can tweak it, play around with this, see if you get some interesting results if you go higher. But usually I tend to just keep it as a default and just go a bit higher in the tensor radius, since usually those tensors are a bit small for my taste. All right, I think we went over most of it. The main part here is the PBF stiffness that we set outside for our mist and for our spray. Just so, let's see if we set this correctly. Yeah, just so we separate our mist and don't have this stiffness applied to our mist as well. So we just get into interesting behavior where there's like some parts that get clumped together and then others that don't. So I think this is it. We went over all the settings here of the whitewater solver. And let's try and see if we can simulate this or if this is still a bit too slow. So first of all, let's save our scene as a new version. 7, just in case. I always like to do that before simulating because sometimes Houdini tends to crash. If we have a look here, and we can already see a much nicer behavior and look to the overall simulation. And if we go, for example, here, this looks a lot nicer and doesn't give this weird streakiness. The thing that we do have to remember if we start to simulate this, we're not going to get our nice foam behavior that we had before because we turned our adhesion off, so it's not going to keep it to the surface anymore. And so to change that, let's jump into the next section where we're going to start to combine both of these behaviors.